All right, so today is just a tiny expansion from what we did last class about long division, synthetic division, finding factors, factoring polynomials, and things like that. So in your homework last night, you were always given a factor. And all the problems, if you look at, is given x plus 3 as a factor, given x minus 2 as a factor. Well, how do you factor it if you're not given one of those? So that's what I'm about to teach you is what do you do when you are not given a factor? How do you find it? So we have what's called this rational zeros theorem. This is all, you can read it. If you have a function, it has integer coefficients, then every rational zero of the function is in the following form. So this is a list of possible rational zeros. So we call it a list of P over Q. P over Q. P stands for the factors of the constant. Okay, your A naught, your constant in the problem. Q is considered the factors of the leading coefficient. Pretty sure I might have spelled coefficient wrong, but I don't know. It's the factors of the constant divided by the factors of the leading coefficient. To be honest with you guys, I have no clue why we use P's and Q's as mathematicians. I don't know why P stands for the factors of the constant and Q is the factors of the leading coefficient. I'm not sure. But all you need to know is it's called your P's over Q's. It's your factors of the constants divided by the factors of the leading coefficients. Now, what's important is that's going to be an exhaustive list. It's going to be pretty big sometimes. So what you need to understand is this is a list of possible rational zeros. Solutions, x-intercepts, all that fun stuff. Possible, which means they're not all going to work. Out of a list of like 20 possible ones, it could be just one that works. So how do you figure out which one works? Look for the one that gives you a remainder of 0. We know something is a 0 of the function. We talked about this last class, and you did it in your homework, where you know something is a 0 of the function if you get a remainder of 0. So not all of them are going to give you a remainder of 0, but some of them will. And if it does, that means it's a solution of the problem. That means it's a factor. That means it's an x-intercept. So out of that whole list, you're going to have to figure out, well, which one gives you 0. And guess what? The only way to do that, guess and check. That's the part that stings. You have to physically go through each of the possible ones and see, all right, is this one going to give me a remainder of 0? Is this one going to give me a remainder of 0? And it is purely guess and check. There are no shortcuts. There's nothing like that. You have to guess and check until you get one that gives you a remainder of 0. So the best way to do this is by example. So, I wanted to cover all this stuff up. All right, so we're going to find all the rational zeros of the following polynomial function. So we're going to use synthetic division. Okay, so here's our function. So the first thing, okay, and it's already actually showing you, is if you're to find all the rational zeros of a function, step 0, the easiest thing to do is see if it's factorable. It's very similar to what we did last semester with quadratics. Is always see if it factored first, and if it didn't factor, then use quadratic formula or complete in the square or something along those lines. So same thing here. Do see if it factors. This is 4 terms, so the only way to factor it is by grouping, and you can kind of tell as you're grouping them together, there's no way that's going to factor by grouping. So now that it doesn't factor by grouping, what you need to do is list out all the possible rational zeros. And the way you do that is your P's over Q's. So we are going to do our P. I'm just trying to zoom in, that way y'all can see this a little bit better. Voila. P is the factors of the constant. So it's the factors of, in this case, 3, because 3 is our constant. So P is the factors of 3. The factors of 3 are plus and minus 1 and plus and minus 3. It's always plus and minus, because technically negative 1 times negative 3 is positive 3. It's all sorts of different combinations, so that's why all the factors will always have a plus and a minus. Q are the factors of the leading coefficient. Okay, this is what's written on the other piece of paper, so this part you do have to memorize. P is the factors of the constant, which is a 3. Q is the factors of the leading coefficient, which in this case is a 2. So, also easy, plus and minus 1, plus and minus 2. Now, this isn't my list. It's not plus and minus 1, plus and minus 3. Your list of factors is your P's over Q's. So I'm going to go through very slowly how to do this, and you'll be able to eventually pick up on some of the shortcuts to list it. So P, one of the first P's is plus and minus 1. Ooh, plus and minus. So it's got to go over the other Q. Well, that plus minus 1 also has to go over that Q. Then I've got that P, plus and minus 3, over plus and minus 1. Then I also have plus minus 3 over plus minus 2. In some of your lists, you'll have repeats. You only need to list it once. All of these you can simplify. So technically, my list that I want to see, and the way I write it, is plus minus 1, plus minus a half, plus minus 3, and plus minus 3 halves. Okay, but if you're trying to get used to it, do it this way. This is your list. This is your possible rational zeros. There will be questions physically on your quiz and test, I'm telling you right now, that just say list out all possible rational solutions. If that is the question on your piece of paper, this is your answer. Okay, these are all the possible. So now I've got to figure out, okay, which one works? How many of them are going to work? So one of the things that you got to remember from day 2 of the semester is that the degree tells you the number of solutions. Degree tells you the number of solutions. Now the problem is it doesn't tell you how many are real solutions, how many of them are imaginary solutions, and how many of them are irrational solutions. These are just the possible, some of them. Okay, plus and minus square root of 3 isn't listed here, but that could be an answer. Okay, but because of what I'm doing, every single problem, at least one will work. Okay, so this has a degree of 3, so I'm going to have 3 solutions. Not all 3 will necessarily come from the list, but at least one of them will. So, now that I've got my list, my next step, as I said, is to do guess and check to find a solution. We just need to find one solution that will work, and the way we figure that out is you will want a remainder or an output of 0. So you're physically going to go through and you're going to do synthetic division over and over and over again until you get a remainder of 0. Now, this is where if you're pretty good at mental math, you can try and figure it out on your own. Okay? So if you're looking at your list and you want to start guessing and checking, are you going to start with a half? No. You're not going to start with a half. I don't know about you. I don't want to deal with fractions. The easiest number to always start with is positive 1. Okay? If positive 1 doesn't work, then go on to negative 1. If negative 1 doesn't work, still do not move on to a half. Move on to 3. See if positive 3 works. See if negative 3 works. Then start going to the hard ones. All right? So we're going to try out positive 1 first. Okay? You can go through and use synthetic division to get the new polynomial, figure out that the positive 1 works, and find out how to go from there. You can also do it in your head. So you can do a little mental math. Okay, I can do some mental math. I can, in my head, do 2 times 1 to the third plus 3 times 1 to the third minus 8 times 1 plus 3. Because remember, synthetic is the same thing as normal direct substitution. So this will save me some time. I know that that's going to be 2. That's going to be plus 3 minus 8 plus 3. Well, what do you know? That equals 0. So that means I know x equals 1 is going to work. So I can save myself some time. Right? If you don't get what I just did, then don't worry about it. You're just going to do guess and check. You're going to do synthetic division. Figure out which one gets you a remainder of 0. If you get what I did, you can do that and skip some steps. But now that I know that 1's going to work, what I'm going to do is I'm going to use synthetic division to find that new polynomial. Okay? So I'm going to use 1. I'm going to see if it works. So I'm going to do 1. I've got my synthetic, negative 8, 3. I need that to be a remainder of 0. In order to be a solution of it, I need it to be a 0. So let's try it out. First thing I do is drop my 2, multiply, add, multiply, add, multiply, boom. That means because I got that 0, that means it tells me a remainder of 0 shows x equals 1 is a solution. Now, say you had gone through this. This is the guess and check part. Say you've gone through it and it didn't work. Well, go back to your list up here and say, all right, well, positive 1 didn't work, so let's try negative 1. Do negative 1, see if you get a remainder of 0. You go until you get this remainder of 0. Now that I have this remainder of 0, now I have my new polynomial, and I now know that x equals 1 is a solution. But what you need to remember is if x equals 1 is a solution, then x minus 1 is a factor. Because remember, if x equals 1, in order to be a factor, it needs to be set equal to 0, so you'd have to subtract the 1. If you're having issues with that, we are about to go through that just in a minute here. But please remember that if this is the solution, this is the factor. If this is the solution, this is the factor. So if I wanted to start writing this in factored form, okay, because there will be problems where it doesn't say find all the rational zeros, it will say find the factors. I would put x minus 1 times this drop down from x to the third to an x squared, so 2x squared plus 5x minus 3. So I have started to factor. I've got that factor. I found it. Now I've got my new polynomial. Now with this new polynomial, I need to see, does it factor, completing the square, or quadratic formula? The reason why it could factor, if it doesn't factor, you use completing the square. If you don't want to do completing square, quadratic formula. Because it says in the instructions to find all the zeros. That means find all the solutions to the polynomial. Which, as we know, once we get down to a quadratic, those are the ways to solve a quadratic. This one does factor. Okay, so this one is x minus 1, 2x minus 1, x plus 3. Okay, so this is the factored form, and case problems do ask for factored. So this is factored form. I'll get my hand out of the way. Sorry, writing on that side is difficult. That is my factored form. But this one asks for the solutions. So therefore, I set each of these equal to 0. So x minus 1 equals 0. 2x minus 1 equals 0. X plus 3 equals 0. So x equals 1, 1/2, and negative 3. And notice how in this case, all of these numbers were in our list. So, the thing about all of this is new. This is last night's homework. So the only new thing is this part and figuring out which one gives you the remainder of 0. Otherwise, this process down below is from your homework. So that's why we're going to be doing some work with what you guys did in your homework last night. Which is why if you have questions about your homework, it's very important that you ask me now because we're just building on top of it. And we're going to keep building again in a couple of classes. So make sure you come get the help you need from last night's homework if needed. All right, so as I said, I was going to talk about factors. Like, what does it mean to be a factor? So this comes back from what we did last semester, okay? That when you're given the zeros of a function, you can find the polynomial. Okay, so we did a bunch of examples like this last semester. The only thing is we only ever gave you 2 of them, not 3. This time we're just now giving you 3. So if you're given the x-intercepts, write the polynomial in factored form. So you're given x equals 3, 4, and a half. Make sure that they are all integers. So remember that was a big thing. So if we have x equals 3, in order to be a factor, it needs to be set equal to 0. So to set this equal to 0, I subtract 3 to the other side. And now I got x minus 3 equals 0. So now I've got a factor. Do the same thing with x equals 4. I need to subtract the 4 to the other side, and now I've got it equal to 0, so that's my factor. Now this 1/2 one was the one that was a little trickier. As we know, if we move this to the other side, we're not done. All integers. So therefore, this fraction can't exist. So what we did last semester, and it just depends upon who you had as a teacher, how it was shown to you. I know how to get rid of fractions. I get rid of fractions by multiplying by the denominator. So I multiply by the denominator. I now have distributed 2x minus 1 equals 0. So now I've got the factor. So factor, factor, factor. It says to write the polynomial in factored form. So therefore my final answer is x minus 3, x minus 4, 2x minus 1. So factors are set equal to 0, solutions are x equals. So I'm reiterating this again. How do you know if something is a factor of the polynomial? The remainder is 0. Okay. The remainder represents the output. Okay, so what you got to remember, we talked about this a couple of times. The remainder is the output, or the y value, for that x value. Okay, so the remainder is 0 if you know something's a factor. The remainder is that output, it's that y value for that x. So there were a few problems in last time's notes that you would go through and you plugged in, I think it was x equals 2, and you found that the remainder was 15, which meant that the x is 2, the y is 15. So here's just a little random concept. It's random in the sense of it doesn't really link to everything we've been talking about other than a couple of things. But it really just makes sure that we can hammer down into you the process of synthetic division without having to put it in a bunch of other problems. So here it says to determine the value of k if x plus 3 is supposed to be a factor of the polynomial. So as you see, we're missing a coefficient. Okay, we're missing k. We want to figure out what that number is. Well, what we can do is synthetic division, knowing that x plus 3 is a factor. If x plus 3 is a factor, that means our remainder is 0. Okay? Because I tell you that the remainder is 0. So I can actually start setting up my synthetic division. So I'm going to make this line just a little shorter. I've got 2, 11, K, and 9. Okay. I know because it says it's a factor, the remainder is 0. So I automatically know that's a 0 right there. I already know. I say it's a factor, so you know that's 0. We also know if x plus 3 is the factor, that means x equals -3 is what we're going to be using here. So the way I teach this, okay, is you just go forwards and backwards until you have your answer. There are other ways to do this. So if you have a tutor, they may show you the other way. I just personally think that the way I'm about to show you is the easiest. And I actually mean that. So my first step, drop the 2. Drop the 2, I multiply. -3 times 2 is -6. 11 minus 6 is +5. Well, I know, and so I'm putting this because I'm going to show you, that in order to get back up in here, I would multiply by -3. So I would get -15. But I can't do k minus 15. I don't know what k is. So I have to stop there. Like I said, this is how I do it. I stop there. So then I say to myself, okay, well, I can work backwards. I know this is 9, and I know that's 0. So we automatically know what number has to go there. It has to be -9. Okay? Because 9 minus 9, that's the only way to get 0. Well, what I also know, if I want to go forwards, I multiply by 3. Well, think about it. If I want to go backwards, wouldn't I just do the opposite? And I do. I can divide by -3. So if I do -9 divided by -3, I can get +3. Now, why I did all this, I have now created myself a nice little equation. I now know k minus 15 equals 3. Well, with that little mini equation, I can solve for k. Add 15, k equals 18. And that is my answer. So you can work your way forwards and backwards to be able to create an equation. Now, like I said, there's a few other ways to do this. Actually, there's just one. And if you want to know the other way, I'm happy to show it to you. I just personally think this is the easiest way. The last thing with this problem that I want to point out that I will ask, is not just if it's a factor. Please know that if I say f of 3 equals 17, okay, that means this is the x value, this is my y value, and as we remember, that means this is my remainder, and this is my divisor. This 3 would go here, the 17 would go here. But this one I said it's a factor, so that's why it's 0, but otherwise you can put a 17 here and work it through. All right, so this will show up in the homework. I am telling you right now, this is on your quiz and test, this type of problem. All right, so now let's move on to the fundamental theorem of algebra. So because this is algebra 2 advanced, all right, the biggest thing about the fundamental theorem of algebra is that a polynomial, okay, so the purpose, we'll just ignore this. A polynomial of degree n will have n solutions. And those solutions could be real or imaginary. Okay. I mean, as we saw with quadratics, we always had 2 solutions with quadratics. Okay. Now, there is a deeper, much deeper purpose to the fundamental theorem of algebra. we're in Algebra 2 Advanced. You don't need to know it. It's not necessary. It's not going to hinder you in any way, shape, or form. And it is talked about again in calculus. If you do end up taking calculus, it is taught to you again. So there's no point in doing it now. So basically, this problem right here is just a repeat of the very first problem we did. Okay, it says to find all the zeros of the function. So that means my first option, my step 0, is to see if it factors. Okay. I'm going to find all my solutions. I should have 3 solutions. Okay, whether they're real or imaginary, you've got to have 3 answers. And I'm going to see if it factors first. And as you see, if I start grouping that together, it's not going to factor. So if it doesn't factor, the only way to do it is P's over Q's and synthetic division. So I'm going to make a list of my P's and I'm going to make a list of my Q's. So my P is my factors of the constant. So my factors of 15. Well, my factors of 15 are plus and minus 1, plus minus 3, plus minus 5, and plus minus 15. Now I need to do Q. Q is my factors of my leading coefficient. Well, my leading coefficient in this case is a 1. So guess what? It's just plus and minus 1. So therefore, my actual list of possible rational zeros is plus minus 1, plus minus 3, plus minus 5, and plus minus 15. So if I put any of these over 1, just get them back. So these are a list of my possible ones. So out of this list, I've got to figure out which one's going to work. Okay? So the only way to do that, guess and check. You can save yourself time doing mental math, and I'll show what that is after I do it all. But you just got to guess and check. So I'm going to start with positive 1. Okay, so I'm going to do it over here kind of small. I'm going to do positive 1. So I've got my coefficients of 1, 1, negative 1, and 15. So the whole point is that I got to get a remainder of 0. That's the whole point. So if I drop the 1, I get 1. Multiply, I get 1. I get 2. 2, I get 2. And if you're seeing what I'm seeing as I'm going through it, I'm not going to get a 15 here. Not possible. So therefore, out of my list, positive 1 doesn't work. So move on in your list. If positive 1 doesn't work, try negative 1. And a lot of you that are doing some mental math are probably telling, well, negative 1 probably isn't going to work either. If 1 didn't, I got to get to a 15. So I do it again now. 1, 1, negative 1, 15. I drop the 1. 1 times that is negative 1. Well, now I got a 0. Now I got a 0. Now I got a negative 1. Uh-oh. This ain't looking too good. And I don't get 0 again. So therefore, I don't get 0 again. Therefore, that's not a factor. So now I've essentially crossed that whole one off. So what's the next easiest one to do? Positive 3. Well, let's do positive 3 again. Oh, boy. So positive 3. So I got 1, 1, negative 1, 15. So I got 1, I got 3, I got 4, I got 12. Well, I'm getting closer. 12 is definitely a lot closer to 15. 12 minus 1 is 11. Uh-oh. Well, now I'm at 33. That's a bust. So 3 didn't work. But as you see, I'm getting close. I'm getting close to that 15. So chances are negative 3 is going to work. And it will. So I do negative 3. So let me move this down. So I'm going to do negative 3. 1, 1, negative 1, 15. All right, so my first step, I drop the 1. I multiply, add, multiply, add, boom. I found the one that worked. So I know this is my winner. That is my winner. Out of all the ones I've tried, I finally found one that gave me a remainder of 0. So this can be a lot. All right, it can be. So the mental math and what I'm talking about is in your head, you can kind of start plugging in numbers directly to see if you would get a remainder of 0. If I plug in positive 1 up here, I can do that kind of quick in my head. If I plug in 1, I know I'm going to do 1 plus 1 minus 1 plus 15. I know that that's not going to give me 0. So I can automatically kind of chop off the 1. I'm going to try negative 1 in my head. All that's going to do, though, if I just make it negative 1, is it's just going to change some signs. This is going to be negative 1 plus 1 plus 1 plus 15. Once again, that doesn't work either. So see how I can kind of skip this and just kind of do it in my head? Same with the 3 and then the negative 3. So if you get what I'm saying about mental math, you can do that. I do it. If you don't, boom, just do this. All right. So now I found one that works. But I have to find all the zeros. So this is my new polynomial. So because I want to make sure that I'm always careful, if x equals negative 3 is a solution, that means x plus 3 is a factor. Then we have x squared minus 2x plus 5. Remember, this was an x to the third, so it dropped down to an x squared. So now I've started to go through it. Now I've got to be able to solve the rest of it, because this is technically going to be equal to 0 in order to find all the zeros. We set it equal to 0. So I ask myself, is this going to factor? Am I going to want to do completing the square? Or am I going to want to do quadratic formula? Factoring is the easiest. Okay, and guess what? It doesn't factor. So therefore, you have to do completing the square or the quadratic formula. It is your call. It is your choice. If you like the quadratic formula, you could do the quadratic formula. Me personally, based off of how I taught my students last semester, and probably how Ms. Schaefer and Mr. Contrato taught you as well, is because this is an even number, completing the square is going to be a lot easier for this one. So I am going to do it by completing the square because that's how I would do it. And you're not in front of me to tell me how you would do it. But I'm going to do completing the square. So I already know this one. It's negative 3, so I don't need to focus on that. So I focus on this one. So I have x squared minus 2x plus 5 equals 0. So I'm going to subtract my 5. X squared minus 2x. I always put blanks. What goes in my blanks is b divided by 2 squared. So b is a negative 2. Negative 2 divided by 2 squared. That's going to be a 1. So therefore, 1 goes here, 1 goes there. Factor the left, simplify the right. Get x minus 1 squared equals negative 4. Now, take the square root of both sides, because I'm solving, so I don't want to find it in vertex form. I want to find the solutions. So I'm left with x minus 1 on this side, plus and minus 2i. Remember that negative makes it an I. Square root of 4 is a 2. Now my last step, add my 1. So x equals 1 plus or minus 2i. Now this one we already talked about. If we set x plus 3 equal to 0, we know that means x equals negative 3. So my final answer, I've got all this stuff all over the place. I don't have anything circled. You have to, on your paper, then write your final answer is x equals negative 3, comma, 1 plus and minus 2i. That is my final answer. That is what you have to have circled. Do not forget the negative 3. You found it. You did the work to know that that's there, so it needs to be part of your answer. So this part and this part, not new. Finding it is what's new. We also know we did this right. We have 1, 2, 3 solutions when we had a degree of 3. Now, the other thing the fundamental theorem of algebra does is it helps us with this problem. So this one looks like the one we did before, about given the following x-intercept, write it in polynomial as a factored form. What the fundamental theorem of algebra tells us is that if we have one imaginary solution, we automatically have the other. So the fundamental theorem of algebra will always tell you if you have positive 2i, you have negative 2i. Fundamental, you can't see that, sorry. Theorem of algebra must have both imaginary solutions. So this is the other thing that it will tell you. So if you have positive 2i, you automatically know you have negative 2i. See how it's not typed there for you? You'll automatically know it's both. You've never just gotten one imaginary solution. You've always ever gotten plus and minus 3i, plus and minus 2i, plus and minus 8i, okay, and so forth and so on. You will always have a plus and a minus. So if I just give you the plus, you automatically know you have the minus. Okay, so that's what the fundamental theorem of algebra also tells you. So now let's actually write this polynomial in factored form with all the integers. So we could do the first two pretty easily. X equals 4, so that means x minus 4 is my factor. Boom, got one. Okay. Then I've got my next one. X equals negative 6, so therefore x plus 6 is my factor. Boom, I got another. Oh gosh, what am I going to do? Well, I'm just going to go with my basics. I'm going to subtract it to the other side. So now I do have another one. Okay. Now what you're probably noticing is, well, that's not an integer. It's not a fraction, but it's not an integer. But let's keep going, and I'll show you why. So now we've got the other one, negative 2i. So therefore I add it to the other side. And now I've got x plus 2i equals 0. Now, in my final answer, we cannot have this. X plus 4, x plus 6, x minus 2i, x plus 2i. Okay, I can't have the i's because they aren't integers. But how can I get rid of them? Is FOIL. FOIL them. Okay, first, outer, inner, last. Put them all together. The x plus 4 and x minus 6, or x plus 6, excuse me, are going to just tag along. First, outer. So I end up with, I'm trying to change pens. First, outer, inner, last. Inner minus 2ix. Negative 2 times positive 2 is negative 4. I times I is I squared. Now I keep going. Well, what I can notice, what's positive 2i minus 2i? 0. And then what we need to remember, what is I squared equal to from last semester? I squared equals negative 1. So that means I can make this I squared a negative 1. So I have negative 4 times negative 1, which is positive 4. So I've got x plus 4, x plus 6. X squared's there. These are gone. That's now negative 4 times negative 1, positive 4. Now I have all integers, and it's in factored form. So those are the two purposes of the fundamental theorem of algebra. It tells you how many solutions you're going to get, and that you're going to have both imaginary solutions. That's all we need to know about it. So these are each of the types of problems you're going to come across in your homework. So if you are confused, please ask me. Okay, if you're watching this in class and we are virtual, that means I'm still on the Google Meet. So if you have questions, hop right back on that Google Meet and ask me. I will gladly work through problems with you. You should be working on your homework, trying to get that all set and done. You do have a quiz next class, so please study. I will be posting the answers to the homework. I believe tomorrow is when it's scheduled to post, so that way you can check your answers to it. We're going to be reviewing a lot before the quiz starts, though, so keep that in mind. We will review a ton before the quiz starts. Please let me know if you have any questions.